Tomorrow's class is not me because they have PSAT. Everybody say hi to Red One right now when you watch this video. They're waiting right now. The last way to factor quadratics was difference of squares. We did not talk about that last time. The rule for difference of squares. We have squares, so two perfect squares, a squared and b squared. Difference, subtract. A squared minus b squared can be factored to a plus b times a minus b. Notice if you FOIL this out, we should be getting what we started. A times a is a squared. A times negative b, a times positive b. Those middle terms would cancel each other out. B times negative b should be negative b squared. So the rule does work. Example 1, factor the x squared minus 25. First thing on problems like this, make sure you recognize it as a difference of squares. It probably is, if it's right under that on the slide, but it's not going to say factor by using a difference of squares. You need to recognize we have two perfect squares with a minus sign. So this one would factor to what? Not 25. 5, yeah. Because we have x squared, 25 is 5 squared. So a is x, b is 5, so we've got x minus 5 times x plus 5. It's part B. It does not. Multiplication. What about part B? Or a minus 7 times 4a. What about B? We don't have a difference of squares right now, do we? 8 is not a perfect square, x cubed is not a perfect square, 50 is not a perfect square. Yeah, just like we talked about last time, always look for a common factor first. If you have a common factor, you want to take it out. In this case, 2x. And now we do have a difference of squares. So 4x squared minus 25 is a difference of squares. Would be 2x minus 5 and 2x plus 5. So just like before, look for a common factor. If you have one, take it out. Then see if we can use factors. Last one, how about part B? 100x squared minus y squared. 10x minus y, 10x plus y. Very good. Questions on difference of squares? Overall, hopefully, it should be easy enough. You guys did that now for one. Good. 5.5. Quadratic equation. Most of the rest of chapter 5, we're going to be solving quadratic equations in one of these 5 ways. Everybody remember how to solve quadratics? One of the many ways you can solve quadratics. The quadratic formula is the last one we're going to do. That's 5.8. We'll get there, but that's not today. The quadratic formula will work. It will always work. Problem is, it's not always the easiest method. So there's a different one that works. we're going to want to choose one of the other four ways. Solving by graphing. Solve by graphing. We'll do that not today. It is in section 5.5, but we'll be doing that on Thursday. Solving by factoring. If we have a factorable quadratic, that's going to be the easiest, fastest way to solve it by factoring. Problem is, not all quadratics are factorable. We'll talk about how to tell if you can factor or not. Completing the square. An important method, but not necessarily always the best way to solve quadratics, but it will be important to learn how to complete the square. We'll use it later this year. I know the last one. We call it using square root. It's an easy method, but it takes a certain type of quadratic in order to use square root. B has to be 0, and that's the only time we can use square root. We don't use that one very often, but if it does happen to be in the form that we can use, it's going to be the fastest. So we'll talk about when to do which of these methods as we move forward after we get to it. So we will talk about solving by factoring today. Like I said, if it's factorable, that's going to be the easiest, fastest way to do it. The zero product property says if I multiply two things and I get 0, if A times B equals 0, then what? A or B has to be 0. One of the two of them has to be 0. What if A times B equals 6? Could I say then A equals 6 or B equals 6? No, because there's lots of things that multiply 6. 2 times 3, 1 times 6, negative 1 times negative 6. We do the fractions, 20 rows, 1 half times 12, and so on. Right? Any other number doesn't work. We only have the zero product property. Therefore, when we're solving by factoring, and actually when we're solving by any of the methods, we're going to want to start by getting our quadratic equation equal to 0. If it's not equal to 0, you don't want to factor it even if you can, because that's not going to help us solve. Always get it equal to 0 first. It's able to solve by factoring. 2x squared plus 9x minus 5 equals 0. First step is always going to be get it equal to 0. If it's not equal to 0, factoring is not going to help us out at all. It is. Good. Step 2, factor. Hopefully, I think we can all factor that. So go ahead and do it. 2 times negative 5 is negative 10. Numbers that multiply to negative 10 and add up to 9. 10 to negative 1. What can I take out of the first two? 2x. Leaving us with x plus 5. The last two I can take out. Negative 1. Leaving us with x plus 5. Factor in x plus 5 out of the whole thing, which would leave us with 2x. Everybody goes to how to factor that. If it just said factor, we'd be finished. Don't stop there because we haven't solved. Anytime it says solve, you want to get down to things. This is where you use the zero product property. It says if I multiply two things and I get zero, then one of those things has to be zero, which means x plus 5 has to be zero, or 2x minus 1 has to be zero. Always a good idea to check solving by factoring with quadratic equations like that. Should not give us extraneous solutions. So it's not like you should have to cross out one of them. It should go check. A little press the pause. Questions on how to do that one? Excellent. You do part B. What's the zero of this function? I've heard that term before. Find the zeros. Good. It's the same thing as the x-intercept. Where the graph crosses the x-axis. You might also hear it referred to as root. Typically, we'll be calling it zeros. So we need to find the zeros of that function. Y equals 6x squared minus 17x plus 12. I'm looking for the x-intercept. How do we find the x-intercept? Plug in 0 for y, right? Y equals 0. The only way to solve quadratics that we've talked about so far is by factoring. This is probably going to be factorable. I don't see a common term I can take out 7 times, so there's nothing I can do to simplify the problem there. So let's do 6 times 12 is 72. How about the numbers that multiply to 72 and add up to negative 17? 9 and 8, negatives on both of them, so we need to add to negative 17. Three x out of the first two. Negative 4 out of the last two. I know when we take a quiz or test, somebody's going to stop there. Don't be that somebody. Let somebody else do it. Make sure you answer the question. Go back and read the question. Find the zeros. The zeros should be numbers, x-intercept. Set each part equal to 0. I get 3 halves, and if I set that one equal to 0, I get 4. We have zeros, also known as x-intercepts, at 3 halves and 4.